Okay, right, let's get started. So good morning, good afternoon, and good evening to everyone from around the world. Welcome and thank you for joining our webinar today with Spire Global, Uncover the Hidden Treasures in Your Maritime Data. First of all, I'd like to introduce our two speakers today. The first one on the left is Bart Adams. Bart is the founder and CTO of Xyzt AI and has held senior leadership positions at Luciad and Hexagon, where he was the product management director and chief innovation officer. Bart holds a PhD computer science at the KU Leuven and a postdoc from Stanford University. On the right, we have Mark Deverill. Mark is Spire Global Senior Manager Sales Engineering. Mark has over 25 years of experience working with commercial data services in the maritime sector. At Spire, he is the maritime information subject matter expert and specialist in AIS, ship tracking, ship characteristics, trade data, research and analysis. So thank you for being with us today, Mark. Next, let's go and talk about the agenda. So what are we going to show you today? We're going to have the welcome and introductions, which we're just doing now. We'll then talk about AIS. We'll then talk about the two companies, and then we'll go into the excellent use cases, the two demos that we have, and then we'll talk about how we can help you at the end. So just a few housekeeping things before we get started. So if you have any questions, then please do put it into the chat box, or we have the Q&A section. So it's up to you. I'll keep an eye on both of those, and we'll get round to those at the end. We'll try to answer as many of them as we can, time permitting, but we will also add them to the follow-up email and have a Q&A section in that. Yeah, the webinar is being recorded, and we'll then have it available to share again, hopefully by the end of this week or within the next 48 hours. So now, without further ado, I'd like to hand over to you, Bart.
All right, thank you, Joe, and thank you all for joining. Today we're going to talk about AIS, and many of you maybe know AIS, but some of you might not know what it is. And AIS basically stands for Automatic Identification System. It's a system that was designed and is in use since about 2002 for vessels to communicate their position, to receive the position of the surrounding vessels, and to use this information for collision avoidance. The vessels communicate not only their position, but also their status, their activity, and so on. So it's a very powerful system, but it also is very useful in the sense that we are logging this data all around the world. And so there's many use cases and business cases in exploiting this data, far different from collision avoidance. And that's what we're going to talk about today. It's a lot of data, and we're going to look into that just shortly. It's a lot of data, and I'm very happy and lucky that we have Spire with us. Mark is joining us today, and Spire is actually one of the leading companies that is capturing this data and communicating this data and providing you and us with this data for all those different business cases that we're going to talk about. And it's really a lot of data. So the tricky thing lies in being able to handle the data and being able to exploit the data to get insights. So it's a real big data set, especially if you start looking at historical use cases. So basically, you need the right tools to handle AIS data. So this brings me to the first poll question, Joe.
Yeah, so we're going to run. Yeah, so we're going to run 3 different polls during the presentation here, just to keep on your toes and make sure you're still there listening and watching. So the first poll question, it is, how many AIS messages are logged daily by Spire? So the poll will now come up, and you'll be able to make your selections. We'll keep it up for about 10 seconds or so. Okay, the answers are coming in. Yeah, I think that is all of them. Okay, so everyone thinks that it is answer number 3 and 180 million.
Okay, thank you, Joe. That is an excellent transition to the next slide. And here I would like to invite Mark to take the word.
Thanks, Bart. So as Bart said, we're one of the leading providers of AIS data globally, probably the leading provider of satellite data, given that we have the largest commercial constellation Spire operates its own constellation of 96 nanosatellites, manufactured, designed, built by Spire, and just launched using launch parties. The Spire service has grown almost exponentially the last 2 to 3 years. We now have, as I say, 96 satellites in service. 6 were actually launched 2 weeks ago and still going through final phases of rollout. So we expect them to add to our AIS data in the next probably 2 to 4 weeks when they come fully online, at which point we will beat 20 million satellite AIS messages a day for the first time. We currently peak at around about 19.4, so expecting quite an increase when new satellites come online. They're fully flexible, they're software controlled, so the payloads can be reconfigured and have been configured several times in the last couple of years to make improvements to our service. So it's a very dynamic, flexible, expanding, world-beating collection of AIS. We also integrate with terrestrial AIS from terrestrial partners, and also uniquely with dynamic AIS, which gives us unique coverage in the congested waterways where there are too many conflicting AIS signals for satellites to receive them all properly. And all in all, it gives us a leading AIS service, which many companies are swapping to, and our business is continuing to grow week on week, month on month, as our satellites and our coverage also grows. Okay. Sorry, I should also mention, we also use satellites to collect other information, weather, radio occultation data, and GNSS detection data for weather and soil moisture, aviation tracking data, very similar to AIS, but using ADS-B technology, and then Earth observation information as well. All available on our Spire website, but this is AIS, which XY, the T has done this preparation around. Okay, should we go on? I think there's one more slide. I think it's great. So this is how we present our services to people who need the data. We cover, we provide tracking data and additional data to maritime customers globally in all different kind of market sectors. So we start with the raw AIS data as a TCP service, then we enhance it in a API that has data cleansing and filtering capabilities. Then we add value to it in our Vessels API, where we combine the different types of AIS together for the latest report, and we add in additional value features like predicted routing, predicted ETAs, matching of the reported destinations, and then enhance data to identify the ships commercially. So AIS will not tell you a lot of information about the ship other than its name, call sign, MFI number, and an approximation of the type. So it will tell you that a ship is a cargo ship or a tanker, but it won't tell you whether it's an oil tanker or a gas tanker or a bulker or a reefer or container ship. And that's where our enhanced database comes in. And then the last thing which we've added beginning of this year is dynamic AIS, where we also integrate with AIS collected from ships which are trading on the international routes. And they're like floating windows. Floating AIS would see those picking up all the ships from around them, which adds a granularity to the congested waterways, which is just not possible from satellites. So the three together give us a truly beating level of service. And let's leave it there for now. I want to see what Bart's been doing with our data.
Okay, thank you, Mark. So just a few words about Xyzt AI. We founded the company about a year and a half ago because we saw that there's so much location data being gathered, not only in the maritime world, by the way, but what we noticed is that there's no real tools that can visualize this data and analyze this data if you look at long periods or big regions. So Xyzt AI is a big data location analytics platform. It's software as a service, so it runs in the cloud. You can just access it from your browser on your computer or even your iPhone if you want. It scales really to billions of records without having you to worry about the performance on your device. And finally, you can take your data live really in less than a day. So that's a short introduction on Xyzt AI. Then back to AIS. So AIS data is basically messages that are communicated by ships with longitude, latitude, timestamp, IDs, and so on. And there's tons of use cases. I'm going to highlight 4, and I'm going to demo 2 use cases. But there's many more. And actually, Spire has really nice data stories on their website that go into all those different use cases. The first one is battling illegal, unreported, and unregulated fishing, which is a huge problem globally. And there's companies such as Global Fishing Watch that are using AIS data to gain insight and to battle this illegal practice. Second use case is incident analysis. Basically, from the AIS data, you have a recording of basically what happened at sea, and you can replay after an incident. And this is valuable information, for example, also for insurance companies. Thirdly, route optimization. Fuel prices go up and down, but still going from one side of the world to the other is quite expensive. So it's really in the interest of operators to optimize the routes and to take advantage of all the economical situations. And AIS data can help with that because you have also the history of the movements and the fuel consumption if that's logged by the shipping company. And then thirdly, traffic monitoring. An important use case that we see when talking to port authorities is the increased attention to greenhouse gas emissions, and especially with big passenger traffic and so on. Ports are starting to monitor what's happening to look, for example, about pollution and to reduce pollution into their area. But there's many more use cases and value in AIS data. And that brings me to the second poll question. Joe?
Yeah, so poll question number 2. Does everyone capture or purchase AIS data? So the 3 answers: yes, no, but I'm considering, and no, I am not considering. Let me bring the poll up for you now. There we go. So if you'd like to make your selections now. Okay, we'll just give it another second or so. I think everyone has made their answers. And the winner is obviously yes. And let me share the results with you. Great. Okay, thank you very much, everyone. I'll stop sharing that and on we go.
All right, thank you, Joe. So let's straight go to the demo. And one of the first use cases I'm going to show is to how AIS data can be used to analyze basically global impact of COVID-19, but also local impacts on passenger travel. So I'm going to switch to my browser here. So this is the login screen. I'm going to log in here to the platform. Basically, what you see now is, let me put this to full screen so you can see it better. What you see now is the admin console of the platform, and it allows you to set up different projects. So for example, if you have a different data set or you have a different area that you want to monitor and analyze, you can create a new project. You can involve your team to share the results or to share the dashboards and so on. You can connect background data, and I'll go back into that. You can connect the data itself, which is basically the location data, which in this demo will be the AIS data. And then you can start analyzing visually and using trend analysis. I'm going to use a couple data sets here that I got from Spire, and the first one I'm going to use is this one. It's actually a data set that covers 2 years of AIS data. It starts in August the 1st, 2017, goes to August 1st, 2019, and it's about 1.4 billion location-related AIS messages. If you go to the visual analytics screen, you immediately get to see all the data. So basically, we are now looking at a picture of 1.4 billion AIS messages, and one of the goals that we had with founding XYZT is that we should really scale to billions of records. So here you see a heat map. It goes from dark blue to white, and it shows basically the number of vessels passing by that pixel or that longitude latitude coordinate on the screen. At the bottom, you see the same data visualized in a different way. Here you see basically the number of vessels, different vessels that were counted on that particular day. So for example, here on November 14, we have about 6,329 vessels in the data set. This is of course not all vessels. This is a selection with the data that I'm also going to use in the demo. And then here, thirdly, on the right side, you see an overview of the attributes in the data. So the data cannot just have longitude, latitude, but it can also have for example, vessel type, and number 16 means a passenger vessel, for example. So here we show a summary of all those properties. And basically, you have 3 different views on the same data, which allows you to really dig into the data and analyze it. And starting from this overview picture, we can start analyzing. And one of the unique things of the platform is not just that it can handle billions of location records, but it can also handle them interactively. So basically, I can apply any filter. And what I'm doing now is I'm applying a time filter to focus on a particular region in time. And the map will update within a second or so, or sub-second update rate. So I can do that for filtering in time. Let me feedback on the entire range. But I can also do that on by filtering on region. So I can zoom in on any region on the map, and it will basically fetch a more detailed version of the information that we have in the location data. And what you should see is whenever I zoom or navigate around the map, you will see that all the different views, they update. So we always get an up-to-date view of what's happening on the map. So let me zoom in a little bit here on the Melbourne area. So for example, here you see some vessels that are at anchor. You see that, and here you see the main lanes. Here at the bottom, you now see for the area in the map, you see the trend line of how many vessels there are. And then here on the right, you see an overview of all the properties in the data. So for example, here I could see that the main shipping operator owner is TT Line in this area. So the system is really flexible in not just showing the data, but also in allowing you to dig down and to really start investigating the data. You can do so by, for example, changing the styling. So what I could do is I could color by an attribute. Now I'm coloring by ID. So basically, we are painting every vessel with a unique color. And then you can see, okay, what's the movement pattern of certain vessels in this area. You can also color by any attribute. So for example, I could color by navigational status. And then you should see that those vessels at anchor, they pop up in this picture. And that you also see here. So for those of you familiar with AIS, 0 means underway using engine, and 5 means moored, and 1 means at anchor. And then by styling and by visualizing your data differently, you can then start filtering on the data. So for example, if I now want to take out all vessels that are underway using engine, I apply a filter, and then my map will update, leaving out those vessels, and I can focus on what I want to focus on. Let me move back to the heat map and just show you what the impact is of being able to handle such large amounts of data. The impact is, for example, that you can really start analyzing global trends, but also seasonal trends. And so, for example, if I focus on this area in the Antarctic region, you would see that there's like this seasonal effect of a lot of travel during our winter months, but of course in the southern hemisphere it's the summer months. So you see, you can compare then what's happening over time. And I'm going to use some comparison tools with another data set to look at the impact of COVID-19. And for that, I'm going to switch to a different data set, which is a more recent one. It's actually a data set from August 1st, 2019 to August 1st, 2020, so a little over a month ago. And it focuses only on large passenger traffic. And the first thing that you should see, now you see, again, the heat map of all the travel of those vessels. But at the bottom, what you see is something which is quite surprising, I would say. Around March 10, there's like a big jump in number of vessels. And I don't know, Mark, maybe you can explain a little bit what that means?
So yeah, that's not a sudden increase in activity, that's an increase in coverage. So at that point, Spire added Dynamic AS Class B to our daily coverage, which meant that we had a lot of small passenger vessels, particularly in the Asia area, picked up by our service for the first time. So that's what that spike is.
Okay. Okay, good. So yeah, indeed. So if I look at the data, and let me disable the background image here a bit, you see that I'm now coloring by collection type, and you see around here the East China area, you see a lot of those yellow, which is indeed dynamic areas. So what I'm going to do is to filter out smaller vessels is I'm going to apply a filter on length, and I'm going to apply it basically, let's take 200 meters. So let's focus really on the bigger passenger vessels. And let me switch back to the heat map. I'm going to invert my heat map to make it more visible on the dark background. And now it goes from white, which is like little vessels in that area, to blue. And what I'm also going to do is I'm going to focus on not just large vessels, but large vessels underway using engines. So again, using this zero navigational status filter. And just by looking at this global picture now of the entire globe, you can see that around March 11, 13, there's like a big drop in movement, so a big drop in activity. And then the question is, how much is there going on? So what I'm going to do now is I'm going to split the screen in two screens. And what happens then is that you get two timelines. And also here at the right, you get basically two columns. This one is for the left screen, or the left map, and this one is for the right map. And now they're still sort of showing the same data. So what I'm going to do is I'm going to reduce my time filter here to a smaller area in time. And I'm going to uncouple the two timelines so that I can basically look at different time ranges in the two views. So let me put this second one on this page, on this filter. And then globally, just by looking to the entire globe, we can see that during this entire period from November to March, and here from March to July, there's about 8% less big passenger vessels moving around the globe. And just from looking at the picture also, you can see there's a lot of difference. Like for example, here in the Antarctic region, and that's of course not only due to COVID, it's also what we saw in the previous data set, a seasonal effect. Typically, I think it lasts, travel in that area lasts, I think until around early April. So it stopped a little bit earlier here. But you see the difference here, it's a huge difference. But also in other areas of the world, like for example, here in around Sydney, you see there's a huge difference in travel. There's a first bump that you see around March 13, but the biggest drop happened there around April 7, 8, 9, something like that. So I can focus my two windows on that, and you see that the drop is really significant. So there's a lot less travel in this area. And by looking at all the properties in the data, we can sort of see what is happening with the different operators. So for example, here on the left side, you still see Carnival as being one of the main operators being active, but it's really dropping here in the right picture. So tool really allows you to dig in. So for example, I can now move all the way to Mexico. There's also an important area here in San Miguel de Cozumel, where there's normally a lot of traffic with cruise ships. You also see here a clear decrease in travel, and where you see also the affected owners, including again Carnival as one of the main cruise ship operators. So a lot of insights to gather out of this data, and I'm going to show another use case later on. I think before that we have another poll, Joe.
Yes, we do. So final poll question is, how do you analyze your AIS data today? Answers are using BI tools, own built algorithms, and we need an easy tool. So let me bring up the poll for you now. There we go. So you can choose your answers, please. Okay, a few more answers still coming in. Great, thank you very much, everyone. And we can see the split, 10% using BI tools, 62% using own built algorithms, and 28% reading the easy tool. Great, thank you everyone. So if you do have any questions, do put it into the Q&A box or into the chat section for when we come to the Q&A section at the end.
All right, thank you, Joe. Let's move on to the second use case, total different industry. Actually, we are located in Leuven in Belgium, which is close to Antwerp, which is one of the main chemical ports in the world. And we also have Rotterdam nearby. So what we're going to do in the second use case is we're going to look at the past year and look at what's been going on with chemical transport in the maritime domain. So what I'm going to do is now I'm going to switch back to my home screen, select a different data set. It's a data set of about 300 million data points. So a lot of data files being pushed to the platform there. So let's start with a quick look at all the data. So here we see basically the entire movement of chemical tankers around the globe during the period August 2019 to August 2020. So it's a lot of data with a lot of potential in it. So again, you can zoom in and out on the data. And what you see here now is the pure AIS data. So you see the vessel types here, you see the distribution of the lengths, you see the width and so on, the navigational status, collection type and so on. So one thing I'm going to show is that the importance of what Mark talks about, the enhanced vessel data that they maintain and can provide. For that, I'm going to go to my Connect Data tab. And here you see I have a lot of data files that are basically the AIS messages. But what I can also do in the platform is I can upload additional metadata. And in this case, it's the enhanced vessel data of Spire. And what you see here, there's also the MMSI, which is serving as the ID to basically identify the vessel. But then there's a ton of other information, such as vessel type, builder, and so on. So what I'm going to do is I'm going to add that data to the platform. It comes as a CSV file. You see some of the content here. It's uploading now. It's going to take a few seconds to process. And then all this information that's in this EVD file is going to be available for analysis. So I'm going to switch back to the visual analytics view. And from now on, instead of just showing the distribution of the attributes in AIS, it's going to show me also the distribution of all the data points that I see here in the view with the additional EVD data. So already from looking at the global picture, you see that Stolt is one of the main chemical operators. But then if I, for example, zoom in on Europe, you would see that the picture changes. There's a few local operators, like, for example, let's take the second one here, which is Spire. So what I can do now is I can filter on this data and just focus on the operations of this particular operator. So I filtered out all the rest and focusing on Spire. And you see that the heat map lights up mostly around Europe. If I use the inverted heat map, I will also see the exceptions to that. And you see there's some travel going on here to Canada. There's also some travel here to Mexico. If I zoom in on that region, I get the exact time that Spire was also traveling into this region. And here you get all the different properties of that particular vessel. So that allows you to sort of dig in maybe into your competition and look at what they are doing. Let's remove the filter again. Maybe go back to the blue heat map. And maybe let's focus on Stolt. So I'm going to remove this and apply a filter Stolt tankers. And there you see they have a much more global reach. You see they have a lot of activity going on here in the main chemical hubs in Europe, which are Antwerp and Rotterdam. You can see when they had most activity there, most vessels there, and so on. And you can also see that they have a lot of travel going to the United States. So again, using the same filters, the same flexibility in styling. For example, also, if I would look at the second global operator, which is, let's take Mitsui, for example, I could make a filter, or I could split the view, for example, the left one filter on Stolt, the right one filter on a different operator, and start comparing. So that's also possible. And then you can see, okay, where are they active? What's the difference, and so on. Do they have more tankers, more vessels? So, for example, you see Mitsui is more active in the west region of the US, while Stolt is more active between Europe and the Houston area here. And you can also compare, like, okay, this is the difference in activity, difference in vessels being active. One other thing that I want to show is that sometimes it makes sense to do analysis on particular areas or particular regions. So what you can do in the platform also is you can upload your areas of interest, which are basically polygon files. And instead of just using them for visualization, you can also define them as being an area of interest. So let me call them areas of interest. And then I choose between background map and areas of interest. And I use name as the label for this thing. And once I've done that and saved, if I then go back to the visual analytics screen, you will see, and let me disable the assets layer for a while to just show you the different areas that I uploaded. You will see that the system will also start analyzing activity within those areas. So for example, here in this area, you see a lot of waiting patterns of those chemical tankers waiting to enter the port of Rotterdam. So what we do also is we basically do analysis of all this data, these millions of data points on those different areas. In this case, we count the number of vessels in the time region, and we order them from most vessels to least vessels. So for example, we see that this area, which is called the Rotterdam area, has the most vessels being visited. And then Antwerp is second after this big anchorage area where there's a lot of activity going on. So this allows you to, for example, say that we go back to Stolt, for example. We're going to filter on them. Let me see the ship owner here. Let me put this filter in again. And then it's going to compute not just for the map, the timeline and so on, but it's also going to compute an updated temporal histogram. And you see that most activity is actually in those two areas, which is basically on the other side of the Atlantic, which is here in Houston. So you see a lot of activity going to those different areas. And I think LBC Houston is probably a little bit more up high. It's probably here. Yeah. So here you see the activity of the Stolt tankers going to that chemical terminal. So a lot of possibilities to analyze the data visually, but also using trend analysis. And that's the thing that's also in the platform. You can do trend analysis to see the impact over time of the different travel, the different tonnage, and so on. So for example, here we are computing globally over the last 4 weeks, what's the difference with the 4 weeks before. And in this case, just looking at all the chemical tankers, there's like a small decrease of 0.2%. But you can also look at the different areas that we uploaded. So for example, in Antwerp, we see that there's like a 0.7% decrease in activity. And of course, you can look not just at counts, but you can also look at tonnage, you can look at the speed over ground, and so on. So short overview of the platform, which basically brings me to how we can help you. But Mark, maybe you want to say a few words first?
Hi, thanks, Bart. Sorry, trouble getting unmuted. I mean, to me, I've been analyzing AS data for a long time now, and this tool is just incredible with how easy it makes it to not only analyze data, but to visualize the analysis as well, and to do dynamic on-demand kind of analysis of very large volumes of data. It's truly unique in its capability. I'm looking at it and just drooling with ambition for the analysis we can do. Things like the volumes, the patterns of different companies, patterns of different terminals, things like comparing voyage speeds and looking for trends in speeds, which is a significant factor in costs operationally on voyages, and tells what's happening in the market in relation to kind of market rates and bunkering and just availability of tonnage as well in relation to speed and how quickly ships are committing to do the voyages. It's all very important information that to date has taken a lot of analysts a lot of time to analyze and is not easy to repeat. And I'm just convinced this tool makes it very, very easy to get to really valuable information very quickly. So congratulations, Bart.
All right, thank you.
Very useful.
Thank you much. Thank you. Yeah, one of the things that I like to say is that a picture tells more than 1,000 terabytes on your disk, and that's actually what our vision is. We really want to make the data visible, but not just visible. We want to really make it useful to extract the insights out of the data. So how can we help you? And by that I mean Xyzt and also Spire. First of all, if you like, there's tons of data, and AIS is like huge, but you need good quality data. There's many ways that data can get bad with AIS also, like spoofing and so on. So Spire is really doing a lot of effort in making sure that the data is of good quality for you, so that you don't have to spend the analysis, the cleaning up before the analysis. Second, if you need a scalable tool to look at the data, to analyze the data and to find insights, we are here also to help. And we can definitely help you with in the maritime domain, but also in other domains. Whenever something is tracked with location, timestamp, and attributes, the Xyzt platform can handle it. And finally, we truly believe that by combining lots and lots of data, good quality data, with a tool that is interactive, that allows you really to move in the data, to move around in the data, using this interactive filtering and styling gives you the opportunity to extract better insights. So to conclude, I would like to thank Mark. I would like to thank Spire for joining us on this webinar, and both Mark and I are happy to take your questions.
Great, thank you, Bart, and yeah, thank you, Mark, for that. So just looking at some of the questions that have come in. First one is, how can you use this tool for route optimization and fleet performance management?
Shall I take that one?
Yeah, fine.
Yeah, so two aspects there. Route optimization, there are many aspects to route optimization. Obviously, the first is distance. And obviously distance plays into fuel consumption, which plays into voyage costs. And we have route analysis tools and route prediction tools built into our APIs, which you can capture the data for from Spire, which will tell you the predicted API routes that we would expect the ship to take. Route optimization is therefore making changes to the default routes or the natural routes and seeing what the effect of them would be. That's not something I'm not sure would be immediately obvious in the kind of analysis that Bart has just shown. But if you were to plot the routes data, then obviously from different ships, you could see which routes are most commonly operated or which are most popular, and that might give you valuable information about why ships are trading on particular routes, which would normally be down to market conditions and costs. For instance, I spoke to a ship operator this morning who was looking very, very closely at route optimization and assessing where his fleet should go for operational cost management. And sometimes they want to go the shortest route to save time because that's the kind of contract they're on. Other times they want to take the shortest or the most cost-effective route, which might not be the shortest. For instance, if you were to plot the emission control zones into the Xyzt tool, then you could analyze how many vessels are going through the emission control zones, which require ultra low sulfur fuel, which is possibly 3 times the cost of high sulfur fuel. And you could look at the difference between routes that go through those areas and routes which don't go through the areas, compare the distance, and therefore compare some simple calculations. So I think visually, this would be a tool which helps you to assess that and see the difference. Fleet performance management is a little bit different. It tends to come into the route and voyage management is part of it. Performance management also is to do with turnaround times, waiting times, times at anchor, times in port, and looking at all those things. And that's very much something that you can look at with this tool. Bart showed you the plot of ships where they were at anchor in the recognized anchorage areas, and you could I'm pretty sure you could intercept that data between ships of a certain fleet and calling at certain terminals, and then looking at how long they were in particular anchorages. If you couldn't do it with the raw data, Spire can provide the event data to say, okay, ships are in these anchorage polygons from this entry time to this exit time, and this import terminals from this entry time to this exit time. And you could put that data into the Xyzt tool and look at the duration comparisons of the events, how long you're spending on the voyage, how long you're spending at anchor, waiting to go into port, and then how long you're spending in port, and what the turnaround times are. So it would just be pulling a slightly different set of data into the tool to allow you to do that analysis. I think that's probably the key aspects of fleet performance management, but obviously if you want to discuss it in more detail, please get in touch and we'll talk through whatever your scenarios may be.
Great, thank you very much for that, Mark. The next one is a bit of a twofold question for you, I think, Bart. Is your platform specific to Xyzt data, or can it be used for other location data? And yeah, do you handle real-time data as well as or only historical data?
Yeah. As I explained, sorry, I was on mute, I think.
Didn't hear you.
Can you hear me now?
Yeah.
Okay. So yeah, as I explained, the platform is generic in the sense that you can basically you have to define what's in your data, what are the properties in your data, and then basically if there's a longitude or an X or Y coordinate and a timestamp, we can handle the data. So we have also customers using it not for maritime data, but for example for in the logistics domain to trucks and so on. So whenever there's like location and time and attributes, it can be uploaded to the platform. Was there a second part to the question, Joe? The question about real-time, yes. Well, the platform also handles real-time data. Basically, and maybe I can show that in the platform. Basically, what you can also do is you can, when defining your data sets, you can define different data sinks. So, for example, what I used a lot in the demos is the gridded ones, where we do the summaries, aggregations on the data. But you can also have a real-time data sink. And in that case, you basically, whenever you push data to the platform, you can also see the real-time position of the vessels and do the same type of analysis and visualization on this data.
Okay, thank you, Bart. A compliment here. So the quality and speed of your density map is astonishing. Are those truly generated instantaneously, and what computer are you using in the background? Can you export the information summarized by those density maps?
Okay, yeah, very good question. So the way that we designed the architecture is so that first of all, we had a couple design considerations. One was that it should scale to more than just a couple millions, what you typically see in GPU accelerated tools. So it should go to billions. And the second consideration was that it should be interactive. So to make it really useful for data analysts, it shouldn't be so that they had to wait for overnight basically to see. What are we running? We're basically running the backend in the cloud. We're running on Amazon AWS. The algorithms are designed so that they are extremely performant in time complexity and data structures. I cannot give away exactly how we do it because I would be giving away the IP. But in this case, we are running just on one node, and we are running within 20 gigabytes of memory. So it's very low cost, which we found also important because if you think about, for example, going to a GPU architecture or a multi-node architecture, I think for going up to a couple billions of data points, it's not really necessary if you design your algorithms well and your data structures well. And that way we can make it cost effective in the cloud or on premise. which with like a distributed architecture and the GPU architecture in the cloud would have not been really the case. So that gives you a little bit of a hint of what we are doing. But yeah.
Okay, and okay, we are slightly over time, but just one more question to Mark. Could the tool run analysis for vessels specifically within user-defined polygons, not just display the polygons?
I think Bart's already answered that question, actually, and the answer simply is yes.
Yeah, indeed. So that's what I showed at the end, is that you could upload those polygons. You can also basically draw polygons on the map, save them, and then use those as areas for analysis. So that's what actually we were doing at the end with the heat map that you saw on the right and the graphs on the right that are particular to a polygon area. Yeah.
Okay, all right, and then just one more question then we have. Do you also analyze the vessel movement split by cargo inside the vessel? For instance, for dry bulk vessels, do Xyzt provide the split between thermal coal, metallurgical coal, iron ore, bauxite, etc.? I think Mark.
If I'll take that question, I mean, Xyzt can split the data by any data attribute that you can provide to the system. So the question then becomes, do you have that information about the specific cargo types? It's not a standard part of AIS, and that is a very specific cargo type that's known. So if you have the data around which specific product is on the ships, and then you can integrate that with AIS data and other data, and then you would be able to split the analysis within the Xyzt tool. And I've seen that done by various maritime organizations who have access to things like bills of lading or fixture data or other kind of terminal cargo specific data, some of which Spire has, but we don't have it globally. And we can happily talk to you about that. But certainly the tool, if you can provide the right information to it, we'll be able to provide that split of analysis.
Great. Okay. Thank you very much for that, Mark. Right. So yeah, just a few minutes over the allotted time, but I'd just like to again thank you, Bart, and thank you, Mark, for giving the presentations, all the great information and the demos, and to everyone that has attended. Then yeah, I'd like to thank you very much for joining. If you do have any questions, then there will be a survey to follow this, and there will be the follow-up email as well. So please do reach out if you have any questions. And yeah, I'd like to wish you a very good rest of your day and your evening, and yeah, watch out for our next webinars coming up soon. So thank you very much. Goodbye, everyone.
Thanks, everyone.
Thank you. Bye-bye.